Imagine a project management system humming along. Users are creating tasks, checking off milestones, and viewing analytics in real time. Everything works perfectly. Deep in the code base, a developer decides to do some routine cleanup. They open the backend database, spot an inconsistency in how task names are stored, and make a quick adjustment. They are renaming a data field from title to name to keep the code looking tidy. To the developer, this feels entirely self-contained. It's an internal cosmetic tweak on the back end, something they assume will have zero impact on the rest of the application. They deploy the code and move on to the next task. But in a distributed system, internal actions rarely stay internal. The true vulnerability of a software ecosystem isn't found deep inside its logic, it's found at the boundaries where different components meet. The moment that updated code goes live, the new data leaves the database and travels across the network boundary, heading toward the user interface. The front-end interface is programmed to search for a title field. Receiving only name, the connection fails. The app acts broken from the inside. Buttons fail and descriptions vanish, replaced by undefined. Meanwhile, the back-end monitors show a healthy system. No error logs are triggered because the database is functioning perfectly. The failure cascades in silence, breaking every external integration that relied on the old field name. The front end crashed because it attempted to fulfill a request based on a contract that had been silently altered. To prevent this, architects treat communication between systems as a formal agreement. An API is more than a list of functions. It is a contract. This contract guarantees exact inputs, exact outputs, and specific behavior. A volatile API returns arbitrary responses without clear structure, forcing the front end to guess and create buggy code. A stable API delivers predictable structure and exact error formats, ensuring reliable communication. This predictability creates a bridge, allowing an iOS app, a web browser, and a third-party server to share data without needing to know anything about each other's internal code. Once an API contract is published, it becomes the foundation for everyone's work. Breaking that structure instantly shatters every system built on top of it. In the era of AI-generated code, the importance of this contract has shifted from a best practice to a structural requirement. AI models generate front-end and back-end code as separate tasks, connected only by a shared API schema blueprint. If that schema changes by a single character, the AI lacks context. It rigidly follows the new constraints, generating mismatched code that crashes together. When an API changes arbitrarily, the AI continues to generate logic based on its last known schema, creating an entire application that is structurally broken before the first line is even tested. Because AI-assisted development relies on these rigid schemas to maintain coherence across a system, API consistency has become the primary bottleneck for scaling software. Stripe provides the gold standard for this level of reliability. They sit at the center of a global financial network, processing billions of dollars across millions of different businesses. Developers trust Stripe because their API schema is exceptionally consistent. When a business integrates with Stripe, they know the endpoints won't change or vanish next month. Stripe prioritizes consistency over cleverness because thousands of other companies have built their own revenue streams on top of those specific data structures. This shows that being explicit with your data structures is always more effective than relying on implicit guesswork. Every future feature and integration your team develops will depend on the stability of the API you design today. In many ways, the consistency of your API contract is the most accurate measure of your system's overall reliability. However, this stability creates a conflict with the need for growth. Software must evolve to survive, but if the contract is an unbreakable promise, any significant update risks cutting off every existing user. When you are eventually forced to change the rules without breaking the promise, you need a strategy that allows the old and the new to exist at the same time. We will look at the mechanics of API versioning in the next episode.